Good morning, everyone. And for those on the Eastern Time Zone, good afternoon. Um, my name is Anand Padmanabhan, and I'm a research associate professor in the Department of Geography and GI Science at the University of Illinois Urbana-Champaign. And today we are going to be doing this virtual consulting office for iGuide, which is the NSF Institute for Integrating Geospatial Understanding through an Integrated Discovery Environment. Um, so so iGuide does this VCOs or virtual consulting office regularly, where we basically share things that are happening in iGuide or the related community to to our audience here. This is kind of an informal session, so feel free to interrupt me at any time uh, and um, and ask questions. So we would like to make this as interactive as possible. Um, Today's topic is on the iGuide platform. We'll be talking about the iGuide platform itself, as well as kind of some of the recent developments like getting GPU access through accessing GPUs through the platform, some of the other features that are on the platform, and we can walk through that. And additionally, we also have a bunch of upcoming VCOs that are on the right side of the screen. So we have like three upcoming VCOs for the 15th, the 22nd, and the 29th of this month on various topics. So please put them on your calendar and join us. So today's VCO again would be myself with Jimeng, who is a postdoc here at University of Illinois Urbana-Champaign, and Yunfan, who is a visiting research scientist here. So we'll be walking you together through the iGuide platform. And we are doing this on behalf of the larger CI team. Okay. So for those of you who have not heard about the platform, what is the iGuide platform? Essentially, it is a cyber infrastructure environment for advancing geospatial data intensive research, convergence science research, and also knowledge sharing and knowledge discovery. So that's what the iGuide platform is designed for. And it integrates kind of, we have some things we call knowledge elements. Essentially, these are kind of, you can think of it as units of knowledge. And we have various kinds of these, like going from geospatial data and notebooks and codes to publications, maps, and other open educational resources. And the idea is like when you publish things, when you have scientific knowledge published, it's usually not in just one format, not just in a publication, but there are also related materials, and these related materials can live together on a platform to give you the complete knowledge of that work. So that's kind of what the platform is designed to do. Um, and it has, I would say, we have four primary principles of the platform. Like, say, it is simple, smooth, scalable, and searchable. Simple meaning like, hey, probably you don't need like a tutorial or a hands-on workshop in order to get to know this. It should be fairly accessible to researchers, easily usable, and it integrates kind of various tools and data sources for geospatial research and education. And it is scalable, so you can work through various kinds of from small data sets, like which you would run in a Jupyter environment, to maybe a larger kind of data sets, which you can potentially run on HPC and other environments. So it has connections to that. And then, of course, that it's searchable, and so you can discover knowledge. And we have AI-enabled search and things like that, which we will talk about. So that's kind of the principles for the platform. And basically, it does is kind of it bridging the research ecosystem gap. So kind of many of these knowledges are in silos. So the platform essentially is serving as a bridge or a connecting middle in order to bridge this gap to facilitate convergence research. Um, the future kind of in geospatial AI. It's kind of not just about algorithm, but also about connecting domain experts and high performance computing. And the platform is kind of positioned to do that. Um, So the geospatial data on the platform also bridges kind of the gaps, providing kind of browser-based access to advanced computing environments like cyberGIS capabilities. So as I said, it's kind of a scalable environment. So you do small analysis and then you can use the HPC to do to larger to scale on larger computing. So uh, and the other thing I would say is kind of it leverages kind of what are the cyberGIS and geospatial AI capabilities. And we have tools such as Smart Search, which help you kind of integrate this knowledge. So that's what the platform is doing, kind of bridging this research gap and ecosystem. And it is operationalizing FAIR principles. So day to day, I guess making this workflow fair, follow the FAIR principles is hard for researchers, right? When you have publications, you go out, but this kind of platform helps to make this shareable by sharing like the associated codes, associated data sets, and maybe even maps and other resources, so that you can point to them, and these are all like linked to each other. So you can easily someone can find your research and can reproduce the research, and kind of enabling this uh, findable, accessible, interoperable principles, mm, reproducible principles there. And for we also have capabilities to issue DOIs for original data sets that you register on the platform. The data sets are easy to register. We can host those data sets, and you can potentially get DOIs for that data sets as well. So it is also integrated with the Jupyter Hub environment, which makes it easy, not just to share the publications, but also like to have like the notebooks, which can help with reproducibility. And we are doing like these kinds of many events in order to help us with this FAIR principles. Um, I should say that the summer school, some of you might in the audience might be interested. The summer school is open currently for students. The application for the summer school is currently open. So if you have students, you are students, or you have students working with you who might benefit, ask them to look at our website and iGuide, i-guide.io, and then you could find the summer school information there. We also do many hands-on training events, basically to help democratize the access to this high-end computing environments. We also have like convergence curriculum online on the platform to support modular, adaptable curriculum development, so that and integration of the curriculum into your classes. So we have this convergence science framework, convergence education framework in the convergence curriculum, which helps you do that. And also there are notebooks and resources available on the platform, which can be used for labs and other things. So we also conduct many series of events, like, as I said, the summer school. We have this workshops and other activities. The platform also has tools for addressing data bias, privacy, and responsible AI. We have what's called the iGuide Data Ethics Toolkit, which is integrated on the platform. It has various kinds of elements like the um, data card, model cards, for documenting data and models, as well as like for research management. We have two things for the project management for research projects. So this would help you manage kind of your projects and your research work, as well as like when you upload data to the iGuide platform. It will ask you certain questions, make this process as simple uh, as possible for you. So those are kind of some of the main things I wanted to get across for the platform. This is kind of the platform environment, user environment. If you go to platform.i-guide.io, you should be able to see this. If you're going there for the first time, you can, or you're not logged in, you can log in, you can register and log in, or you can just log in to the system. Once you log in, you can see your profile or profile page or a photo or something like that. that you can that will tell you that you're logged in. And we use CI logon for integration. So essentially, if you have a US or other even international educational institution accounts, you should be able to log into the platform. So this is how to sign in. On the top right corner, you can sign in with your educational account. If you don't have educational account, you can use like other things like Google and uh, GitHub, but the set of features would be limited for you, and you can reach out to us at help@i-guide.io. So yeah, so for anything, not just for this, for anything with the platform or others, if you need any help with it, you can send email to this email address. Once you're logged in and you are on the platform, you can explore certain knowledge elements. Um, we have 6 of those. You can explore them. I talked about many of these in the previous slides. So go to the, I would say, go to the platform and explore the knowledge elements. On the front page, you will also see 3 things that iGuide has worked towards, which is map, connect, and discover. Map, essentially, you can say transforms geospatial data into knowledge and insights. Kind of, you can explore map and the data sets that we have on a map interface. If you click on that, connect, essentially, the iGuide platform itself is the connection fabric, which helps like scientists and connect with knowledge on the platform. So you have basically various knowledge elements on the platform. You can explore them, and you have a convergence knowledge networks that you can see. If you click on the connect, you will see a graph of how these knowledge elements are connected to each other. And with discover, you can kind of find knowledge elements through intelligent search, through our smart search and iGuide AI capabilities. We will have maybe a little bit more on the smart search today. Yunfan will be demonstrating to us a little bit about how to use LLMs there. So he is kind of the primary developer of the smart search. So basically, we can do both knowledge, keyword-based search on the platform, but also smart search, which is kind of the natural language queries powered by iGuide AI. And it is the unique thing about what we have on the platform is it's just not going to return to you an LLM, a generic LLM response, but it is going to constrain this response based on the knowledge elements that we have on the platform. So the idea would be, hey, if it can find the relevant knowledge elements, it will answer based on that knowledge elements and link to and provide you with links to those knowledge elements as the related elements on which the answer was based on. And of course, you can contribute knowledge elements to the platform, right? So you can contribute, you can upload your own data sets, codes, notebooks, and this should be easy to do. If you go on the right-hand side on your profile, you click on your profile, there is a drop-down button there. You will see, like say, contribute new publications, data set, resources, and others. And then you can share the knowledge elements. Of course, the other thing you could do is launch the Jupyter Hub environment. So check if you're logged in. It should say like login. It should either have a profile picture or a profile avatar for you. And then that should, if you're not logged in, this button will be grayed out. Or if you are using like a non-educational institution account, this might be grayed out, and you can reach out to us at help@i-guide.io. If it is, like, you can launch the Jupyter Hub directly, or you can go to a knowledge element like a notebook and then launch Jupyter Hub from there. Okay. So today we will also be discussing about one of the very new features that that we have developed on the platform, which is kind of accessing the GPUs. Currently, it is available to friendly users, and both Jimeng and Yunfan will be demonstrating to us the things that they have done initially with this access. The idea here is with the Jupyter environment, when you click on the Jupyter environment right now, it opens kind of a CPU only session. So like most of the code will run on CPUs. But this new feature will allow you to launch things like, for example, notebooks that are based on geospatial AI or that need geospatial AI capabilities and need GPUs for that can be launched on an environment that has access to GPUs, and it has like CUDA libraries and things like that. So you can access these um, from your from your environment there, and you can run the code. And that's what both Jimeng and um, Yunfeng will show us. And it will be available to everyone in the near future as we do our next release on the platform. So thank you for our sponsors, and this is kind of my portion of it. I'll pass the baton on to Jimeng. As I said, Jimeng is kind of is a postdoc here at the University of Illinois, and he is also one of the researchers in the AI, geospatial AI kind of field. So Jimeng will share with us kind of what he has done with accessing the GPUs on the platform.
Thanks, Anand. So thanks, Anand already gave a good introduction. So I just skip it and try to jump to the demo, GPU demo. Let me share the screen. Is it clear to observe?
Yes, we can see it.
Okay. Yeah, so I will give us some introduction on how to use the GPU on iGuide platform for your research. GPU mainly the full name is a graphic processing unit, mainly maybe to accelerate video processing, maybe make the video more smoother or with good show on the screen pretty well. But for here, for our researcher, maybe our main purpose is to use GPU to fasten our training process, especially when you deal with some like deep learning models. It will save your time. I'll start with introducing some common GPU operations. First one is how to check GPU information. So this one is the common one I use a lot, but it's not the only one. So if you're familiar with PyTorch, which is a very popular deep learning framework, so I'm using PyTorch, using Torch here as an example. So first step, if we need to import this torch, and if you run this cell, you will see torch connected to CUDA. CUDA is a kind of like a framework to operate the GPU resources. So if you start from Torch, which is the deep learning framework, connect to CUDA, and to check if this GPU is available or not. So here, I just run this cell. If it returns true, that means your GPU is available. And if you want to check more information, for example, here, check the name. Here, I just run it, and here it will show the name of GPU. And if you want to count how many GPU can be available on the platform, you can simply run this cell to, here says torch CUDA device count. So for currently, we have one. And if you're familiar with like terminal command lines, you can also run this NVIDIA -SMI. It will directly show some more detailed information. Like here, we have the GPU name, and we have a GPU like a memory, and here we have a CUDA version. Like the CUDA is again is try to connect with GPU to operate GPU. And here shows how many GPU. For currently, we only have one. So also you can also tell from here, this is a GPU ID, like how many GPUs can be available. If you have more here, should be like a 0, 1, 2, 3, maybe 8. And the thing is how to use that. So we we always compute something like using CPU. We're already familiar with that. But if we want to accelerate this process, computation process, we need to upload our data and model to GPU from CPU. So here is the thing. Let's say we have a tensor. I call it X CPU, which is a pretty simple one, 1, 2, 3. And if you print it and you print this tensor and print like where the device this tensor locate at, then you will see this is a tensor 1, 2, 3, and now the current device is CPU, is on CPU. But now I want to use GPU. How can I do that? You can try to upload this CPU, the sensor on CPU to GPU by simply run this line, just a one line. That means if you want to access GPU, it's pretty simple, just a one line. After you check the GPU resources available, you use this one line dot CUDA to upload your data from CPU to GPU. So here is what we got. X, I call it XGPU. If you print XGPU and XGPU device, you will clearly say, oh, this is a tensor still, the same tensor, 1, 2, 3, but the device is changed. From here, you see here, there's no device. Actually, the default device is a CPU. But now, after you upload the data to CPU or to GPU, you can tell the device here is CUDA. Why is CUDA 0? Because currently we have only one GPU. That's why the ID here is like 0. If you have many, you can also upload the data to other GPUs. And another way is to use, maybe this one is more like a formal. You can define the device. The device here is CUDA. Basically, that's the default setting. If you want to assign like a specific GPU, you can assign maybe here is a 1 or 0 or some other, maybe 8, 7. Depends on the resources. And we can also use this command to upload the data from CPU to GPU. And you can see here, we can also observe the same thing. This X1 is the tensor on GPU. So that's for data. We can also upload a model because if you want to compute, if you want to the model run on GPU, you not only need data, you also need a model. So that's why you also need to upload the model to the GPU. How to do that? It's the same thing. You just try to use this line like a .CUDA. So this is like a default common way. You can also, again, like assign some specific information like this. Yeah, and that's one way. And if you define this device like here in this way, that means you can always define the device you want to use, and then you upload the data or model to this specific device. Here maybe it's like I just give it maybe 6. So that's a basic operation on data and model uploading to GPU. Now, next I will give a like a concrete example to run it. So on our iGuide platform, there already a notebook called the Quick Start to run Aurora. Aurora is a weather foundation model from Microsoft. If you go this notebook and click here, run this notebook, and you will jump to here to open this one, to open like this. And I'll just show you using this example to show how to use GPU resources. So again, this is like maybe a quick introduction on this notebook. Here is we are trying to use the Aurora weather foundation model to make some weather prediction using GPU. So here is kind of overall framework. Maybe we can ignore some details, but one thing you have to know is this is like in the middle is kind of the Aurora model. Let's temporarily ignore some other details. But the input we have to be clear. Input times t minus 1 t, that means we consider the time, the weather from the past 2 time point. And here the middle one is our real model. And then we want to make the prediction for the weather at t plus 1, the next time point. So that's all we want to do. But in this process, we are using GPU to get a faster prediction. How can we do that? Let me try to run it. So again, or maybe I can specify that there are many kernels here, but if you want to run GPU, you need to select this GOAI dash GPU kernel. This is the correct one you want to use GPU. So you run it. Here is a kind of a check a Python version or install some passage. This notebook already include that. But the thing is, here is to prepare some data. If we want to make prediction for the future weather, we need some input data from the recent past. So here is what we are trying to prepare the input data. Because there's how to prepare this data is a kind of complicated and it's another story. But here, let's temporarily here is consider this is the input is already known. You can easily run this notebook and this cell. Okay, that means data is ready. We consider this batch as the input data from the past 2 time point as input, and we throw them to Aurora, this foundation model, make prediction. Now, what we need to do next is to import this Aurora model. The Aurora model is already pre-trained by Microsoft and also uploaded to Hugging Face, so you can easily import this model from there by running this cell. So okay, now it's good. By the way, there are some different like a method to import that, but you can be using the default one. If you want to play it with more details, you can try other options like this one or or specify some detailed requirements. So model is ready, and now the third step or the last step is to make prediction. If we want to make a prediction, model have 2 modes. One is for training, one is for evaluation. But here we want to make a prediction, we definitely want to go with evaluation mode. So you can just set say model.evaluate. That means you are using the model for evaluation. Okay, so let's run it. And if here is we haven't used GPU, that's why here that means we are running this prediction using CPU still. And here is the prediction result, and here compute like the running time for this operation for this prediction. It takes like 0.6 seconds around. And how about we use GPU? Let's take a look. Again, we need to upload the model and the data to GPU using this to counter this line. Just give a couple seconds. Oops. Sometimes this kernel, if the kernel say kernel needs restarting, you just easily go click OK and run it again. Maybe let's run from scratch. Yeah, let's just repeat what we did. Import something, prepare the data as input, and the next step is import this model. So, and we set this model to evaluation mode. And upload the model to GPU using this coder. Oops. Yeah, sometimes this process is still not that stable. I'm not sure why. Maybe like many people are using this kernel. Sometimes this session need to restart. Let me try to close this one maybe. And then restart here. Yeah, you can tell this process sometimes also takes some time because we need to import some package. This importing process also takes some time because this torch is like a huge, large deep learning framework. If we want to import all functions from there, it will take some time. And here is what we prepare the data. Let's use this one. This data is smaller. And also this Aurora importing process also takes some time because Aurora, if I remember correctly, this model has like 278 billion parameters. You can imagine this is like a monster model, and we want to import it. Sometime it takes some time. So we can import like this and set to evaluation. Hopefully we can run it this time. It will take like some time like this. Okay. Oh, it comes out. Why you can tell if we're using CPU, it's take like around 0.8 seconds. But why this process takes so long, take 9 seconds? That's faster or slower. Actually, this process happen. Let me see here. This should be GPU. Yeah. Why this happen? Because we already uploaded this data and model to GPU. Why this is slower? Take a long time because this time include different steps. The first step is to upload the data and the model to GPU. It takes some time. And then you already have your data and model on GPU. You want to compute make the prediction using the model on GPU. It also takes some time. So I would like to say this process is slow because of the uploading process. Why? Because if we want to run this again, you can see this only take like 0.08 seconds. This is the exact time for actually here is the GPU. That's the exactly time for prediction, for making prediction on GPU. But why this like a long time? Because this time including uploading process and make prediction process. So that means uploading process take a longer time. But if you want, once you upload the data and model to GPU, you want to make a prediction, it's super fast. You can tell here is 0.02. And if you're using CPU, it's kind of 0.7 seconds. How many times they faster? Maybe at least maybe 50 times faster. And you can see, you may wonder and say, here is less than 1 second, and here is just like around 0.02 second. But you can imagine this data is not that big. If your data is huge, it's big. Maybe if you're using GPU to make this one prediction, where is that? Right here. Maybe it takes several seconds. But if you are using GPU to make prediction, this prediction just take like less than 0.1 seconds. So that's a super faster and will save your a lot of time. And again, this is just to make one prediction. And if you want to use training, training you have many iterations, many epochs. Every epoch you need to make a prediction multiple times. So if you want to, if the calculation process will take a longer time. But if you're using GPU, it's faster. Let's say this one. This one is kind of here is make a prediction for only one time point. But here, if you have a step 10, that means you need to make the prediction 10 times for to the future. And it's also it's around take 0.2 seconds. It's still faster than the prediction using CPU here. But here is like make one prediction, and here you are making 10 prediction. But the 10 prediction, you are still like take less time. Okay, so that's the process on how to use GPU and to fasten your process. And I also want to show some issue. So for this one, I'm using a very huge data set. Not a data set, it's kind of like an input sample to this foundation model. Here is a kind of global data on this January 1st, 2023, this day. And the resolution is 0.25. It's kind of huge. It's especially, you can tell from here, right? That's the data shape. It's a longitude and a latitude. This 700 and by 1400. So for this huge data set, what happen if you want to use GPU? Here is what happen. If you do the same thing, upload the data and the model to GPU, if you want to run it, something happen like this. Say out of memory error. Why? Because this data is kind of huge and the detailed information say occurred out of memory. I'll try to allocate this memory, but the total one like just 10 gigabytes, or maybe that means your data or your model is too large to adapt on this GPU. Because if you remember the GPU here is 10 gigabytes, that means you either have a better GPU with the GPU with the larger memory, or you can take some techniques to reduce your model or data. So that's a kind of a solution, like a typical solutions to fix this CUDA out of memory issue. Yeah, so that's the common one. I hope you can play with that and let us know if you have any questions. Yeah, thank you. And then next, yeah, I just give it back to Anand. My part,
Yeah.
yeah, it's pretty much it.
Yeah. Thank you, Jimeng. Yeah, any questions for Jimeng? Or for my part as well?
Yeah, once you play with that, you may have more questions on how to use GPU or how to fix some possible
Yeah.
errors.
And as I said, like this is kind of we are just building this out, and it is available for our only friendly users at this point. So this kind of errors are expected, and Jimeng and others are giving us feedback. So the CI team is working on it to fix it, and so hopefully when we release it, actually to be available to everyone, we will not have these kinds of issues pop up.
I mean, that's the issue is expected, especially for the real practical
Yeah.
application. You cannot limit it, say, oh, how large the data sets could be. That's possible, but we do have solutions to fix it. No matter from your side to take some techniques on manual, like operate some data or the model. But from our part, we can like enhance this memory size and to provide better memory.
So if no questions, we have one other part for today. Yunfan is going to be talking to us about the notebook he has. So Yunfan, maybe take it away.
First, thanks, Anand. Let me share my screen. All right, here it is. So hi everyone, my name is Yunfan Kang, and I'm a visiting research scientist at the University of Illinois, and I'm also the lead developer of the smart search system on the iGuide platform. So what you are looking at here is the user interface of the iGuide Smart Search. As Anand introduced, so this is like a chatbot or a search agent that allows you to ask questions and it will grab the information, like the related knowledge elements on the iGuide platform to answer your question. So those are actually clickable pages. So if you want to know more, you can just click on that. I can also show you real quick how it looks. So this is like the landing page for the Smart Search. And if you want to ask any questions, you can type it here, or you can click on one of those example questions. It will go through several iterations of reasoning and try to find related information and also explore different aspects of the question. And it's also able to solve complicated problems like multi-hop questions. For example, you may ask who is the author of something and what are the other works from this author. So the goal is to make use of the iGuide knowledge base to answer maybe research questions or just any kind of questions you may have regarding the geospatial problem and to make it more reliable. And I just created a notebook actually yesterday because we have the GPU available. So I want to demonstrate like how you may make use of the GPUs on iGuide platform Jupyter Hub and try to deploy a large language model and maybe also write like a simple AI agent. So this notebook is already publicly available, but since we only have probably 15 minutes, I will just go through the snapshot here to give you an overall idea. And once the GPU is available for every trusted user, you can simply launch this notebook and try that out. Or if you have resources on your own local computation environment, also feel free to download this notebook and try it on your own, maybe your own GPU or like a MacBook. So to get started, the first thing I tried, because I'm so excited, is to try to verify the GPU information. So the GPU we have in the iGuide platform Jupyter Hub is an A100. It's actually 1/4 of the A100, if I understand it correctly. And with this GPU, I will be able to deploy a small large language model or a tiny large language model. And the one I'm using is Q1 or Tianwen-3 1.7 billion model. It's a pretty small one and it's pretty capable. So one of the shortcomings of using such a tiny large language model is it has, well, from the user perspective, you may feel that it has limited kind of knowledge. I mean, when it comes to a certain fact, and we will see how it actually behaves and how it's like you may resolve this kind of limitation with an agentic AI agent framework. So in this code block, what I did is I specified the model and I pulled the model from Hugging Face. It actually, when it actually runs, it will take like 1 to 2 minutes and it will get loaded. So once you have this cell run, you will have this Q1 model running on the GPU of the iGuide Jupyter Hub, and you can directly go ahead and query it. So you can, I think almost everyone has used large language model platforms like ChatGPT or Cloud or Gemini, and it's pretty simple. It's also almost the same way to talk to your self-hosted large language model. In this case, I'm just asking what is NSF iGuide? I mean, we are part of the iGuide ecosystem. So I just wonder whether this small large language model, and it's actually from a newer generation, to see if it has the kind of knowledge to answer this kind of problem. I set like a system prompt saying you're a help assistant, just help me answer this question. And if you actually run this notebook, I actually made it to return in a like streamed fashion, like how you make use of the ChatGPT. And once we send the message to this small large language model, it's a thinking model, so it has this think block, and it infers that okay, the user is asking about NSF iGuide. It actually does not have any information about iGuide, but it knows about NSF, so it tries to kind of infer what it has without, because we're just asking the large language model as is, so it's not referring to any external resources. And it turns out after the think block, the answer is iGuide, and this part is actually wrong. Is a program, it's actually made up, so we call it large language model hallucination, which means it's actually trying to come up with some fake fact and answer the question kind of confidently. It seems that it knows what you're asking, but it's actually not. But on the other hand, as you can see, it actually has reasoning capability. So we can make use of this capability in our own researches or development to make use of those small large language models to do more things instead of just relying on its own capability. So to make use of that, I actually tried to create an AI agent. Because it fails to answer the question correctly, if we give it, give the small large language model more reliable resources, just like what we did with the smart search, although the smart search is relying on the internal knowledge base, and we use different search methods like keyword search, semantic search, spatial temporal search, as well as graph traversal to fetch the kind of the reference documents. But in this case, what I kind of try to demonstrate is to use a simple search method called DuckDuckGo, which is a free to use search service. You don't need any kind of credit or credentials to use, not like Google search. So it could be like a easy starting point for you to start prototyping your AI agent. And I was trying to create an AI agent that combines the search capability with the tiny large language model. And I'm using the Hugging Face pipeline as well as LangChain, which is AI agent framework. But this is actually a pretty simple one, and you don't have to use like a specific framework. But just for simplicity, I try to define an agent with the DuckDuckGo search as like a tool that the agent is able to use. And I'm still asking what is NSF iGuide. I also define some kind of behavior because, well, this is a pretty small 1.7 billion. You can probably run it on your own, maybe just a meter level gaming PC, as it won't take a lot of virtual memory. So actually, to make it behavior more predictable, I actually define some prompts like asking the small LLM to decide, given this question, if you have enough information, just go ahead and answer it. If you don't, try to issue a search query. And if there's a search query, go ahead and call the DuckDuckGo search method, and then you can make use of the search results to try to answer this question. And after that, I try to run it, and it will ask the same question, which is what is NSF iGuide? The small LM basically try to do the same thing. Okay, I don't know what is iGuide, but this time it actually decided to call the search method, and it went ahead to search NSF iGuide through DuckDuckGo. And here the DuckDuckGo returned several kind of web pages. I'm sorry, it's not like well organized, but probably can see that there are several different results about our summer school posting, the iGuide platform, some NSF information, and our weekly updates. So in this case, this agent actually make use of the search results to find reliable kind of references for the large language model to generate the answer. And with these references, it thinks, okay, I can now figure out what an SF iGuide is. And according to the documents it got from the search method, it tries to combine the answer, and then it comes to this kind of final answer, which is iGuide platform developed by NSF. Although it's still not very reliable, probably because of the trivial search method I have, and I did not configure a lot of other things. But I hope this can show the kind of potential of making use of even a tiny large language model with your own method or tools for probably to even you can use it for like a demonstration of your own research method. Like what I did before is to kind of host my own research algorithm, and I give descriptions of what this algorithm is, how to make use of that in terms of input and output, and I basically decouple and decompose my own workflow into several different modules and give those to the large language model under a certain AI agent, and it is able to do some sort of spatial analysis like given a query that can actually select the correct method to read the data, do the analysis, and do the visualization, and return the description as well as visualization to the user. So that was actually a demo I did in ICDE 2024, which was like already a while ago. But now things are getting simpler. With GPU access on the archive platform, you can actually prototype this with without even like buying credits from those major LLM suppliers. You can deploy your own small large language model and do the same with like small large language models with thinking capability and with your own algorithm. And I have a last block, which is like a longer prompt, because I realized that if I just ask it to issue a search query, sometimes it will just do search query, which is not reliable. So this is like a something like an example of how I was trying to do the prompt tuning just to make the behavior of the AI agent more reliable. But overall, it's a pretty simple demonstration of how you can deploy a tiny large language model and integrate the capability of generative AI to your own research, whether it's about reproducing your own kind of research workflow, analysis kind of pipelines, or you just want to use it for fun. You just want to deploy your own large language model and wrap it in an AI agent. And that will be possible and also made even easier on the archive platform with the GPU support. Yeah, this is the end of my notebook, and I will hand the stage back to Anand.
Thank you, Yunfan. Any questions for any of the speakers today? So as you can see, this is mainly cutting edge kind of research work that we have been doing on the platform that we are sharing with you. So yeah, feel free to reach out to us if you have any questions or interest in exploring this more. So we're happy to engage with the community on this. So last chance for questions. Thank you.
Oh, hi, Anand.
Yeah, go ahead.
Can I ask a question?
Sure.
Yeah, so great presentation, Jimeng and Yunfan. So I have a question. So recently we got research project trying to developing a kind of LLM enabled decision making system for dairy farm. So it's funded by Dairy Management Incorporation. It's kind of funding through USDA and the industry. So I'm wondering, will the guide platform will be able to helping to, let's say, host or deploy such a farm management system. Let's say we are going to run our model and also will enable the farmer to provide their, let's say, farm management priority. Let's say they want to maximize their farm profit versus they want to balance with their environmental sustainability, for example, reduce the emission and so on. Yeah, that's a question like how this large language model can help on this process model and optimization, but also how the platform can be used to deploy such applications. Yeah, thank you.
Well, thank you so much for the question. I think I probably won't be able to answer whether we can host it directly, but just to based on my own understanding, I was trying to decompose what you have described into different components and see what we can provide you with. So the first of all, I think the system you described, I'm not sure about the development status, but according to my own kind of past experience as well as what we have been working on, should compose of probably two major parts, right? You have your own workflow and you want the large language model to make decisions like routing or select the correct function or tool to perform this. and at the meantime, you want to have access to a large language model, and then you probably want to package this whole system and make that available through the iGUIDE platform. I'm just wondering if I understand it correctly.
Right. So, one, I think, basically two level of question, right? Firstly, how this large language model or the tiny language model you're presenting can help basically to run a process model and then optimize. For example, we might apply some AI algorithms further to optimize this. For example, a prompt, a farmer can provide input, right? The constraints, their farm operations, their decision making, and then what's their priority, the goal of this kind of optimization. Two is that, let's say, eventually we are envisioning might have, say, farmers from Middle West, from Northwest, right? Like a cross-relation to access this, say, interface, right? So question maybe Anand maybe have a better idea how this platform at our center can help enable that access, right? For example, the prompt might be have some tokens, right? Might create some tokens. How can this be enabled to make that possible?
I think I understand it. And if I kind of do an analogy, it's actually pretty similar to what we already have on the platform, which is Smart Search. Although I understand it's for different purposes and it will call on different functions. But if I use that one as an example for the kind of routing and optimization part, I do have different kinds of for example, I'm only doing information retrieval in that pipeline, but I do have different search methods, like keyword search semantics, such as I described before. And if it's about a certain location, I will also call on some kind of optimization, try to define a boundary and use spatial temporal search to find more accurate and like search results related to the location. And from prompts, I'm also doing query augmentation, try to, so in your case, probably a farmer asks a certain question and we can revise that query and make that more fitted into like finding certain aspects of data or loading certain algorithms. I think this is a perfect use case for large language models, whether like a big one or a tiny one, like what I was using. Because in that notebook, the reason why I was using a tiny one is because the limitation on resources. But we do have our own self-hosted large language models. Like it can be like up to 100 or 200 billion parameters. So those are already like medium-sized. I mean, according to my own understanding, pretty capable medium-sized self-hosted large language models. So I think the capability of the large language model could be like a perfect fit for this use case. Since we already have like a running example, already deployed system on the iGUIDE platform, I think it will also like probably kind of convey some kind of symbol or signal that I think the system you described should be deployable on a platform like the iGUIDE platform. And I think nowadays everyone is doing something similar, like try to reproduce or enhance the existing algorithms or a decision-making process with large language models. And I would definitely encourage those kind of collaborations and explorations on those aspects.
Yeah.
Cool.
Thank you, Yunfan, for that. We would be happy to explore if there is a particular model or particular research collaborations to be had. iGUIDE would be happy to explore that.
Cool. Thanks, Anand.
Yeah. Great. So I think in the interest of time, we should wrap this up. We are over our by allocated time. At any point, I guess if you have any questions, further questions, feel free to reach out to us at help at i-guide.io. help@i-guide.io. Thank you, and we'll see you here in another VCO. Bye-bye.
Thank you. Bye.